All right, cool. Thanks for coming. This is the last session of the conference. It's a Friday evening, Friday afternoon. This is perhaps the most boring talk title I've ever submitted. So I'm really pleased by the turnout.
I'm excited.
Well, there we go. I'm a programmer as of a few years ago. I'm a DBA now. Currently, I'm managing a lot of big databases, Postgres databases. We have a few Oracle databases, but we keep them on only the small data sets for what I hope are obvious reasons. We do have databases that go over 10,000 tables. We've got individual tables with over 1,000 partitions. This is, in fact, the origin of this talk idea. Someone was pointed out to me that conventional wisdom in the Postgres community was you don't want to partition more than like 10 or 100 partitions for your tables. And I was like, well, we've got daily partitions going back for 4 years in this one table, and I haven't seen any problems. Maybe I'm not looking close enough. So I wanted to find out, what are the limits? Where is Postgres going to fall down? Pardon me. Is that good? So I'm going to examine a few different partitioning strategies. I'm going to examine the effect of increasing the number of partitions, particularly on reads and particularly on planner times. And I am going to answer the question, is there a hard limit to the number of partitions in a table? And the answer is yes. There's a soft limit, too, that you're much more likely to run into. What I'm not doing, I'm not going to be talking about different programming language implementations. I know that's sort of de rigueur for trigger conversations. People are all like, well, you should use C, you should use Perl, you should use anything but PG-SQL. I'm not going to discuss the effects of hyperthreading, which is another fun little discussion topic that often pops up in performance-based talks. The talk is not as quantitative as I'd like. I got a whole lot of data, and only after my EC2 instances had been destroyed did I realize that there was interesting stuff that I wanted to get more data about. Unfortunately, there are open questions for me that I did not manage to answer. However, I do have a lot of data. I'd end up with a lot of data, and I've pruned down the data to what I feel is the most interesting stuff. Okay, about the programming language thing. So I'm just going to touch on this, and I don't have any quantitative data on this because I wasn't able to run C versus PG-SQL tests on the same hardware that I ended up running the rest of my tests. So I didn't want to compare apples to oranges, but I can safely say, yes. C is faster, but it's not way faster. Like there's a notion that you're going to get like 5 to 6 times the number of inserts if you use C triggers instead of PG-SQL triggers. That didn't hold up in my examination. You got like 1.6, 1.7 times the insert speed, which is it's something you might want to invest in. PL Perl, I don't think that getting 1.3 is necessarily worth the additional overhead. But I'm more comfortable with using PG-SQL in a Postgres database. So your mileage may vary, but that's I promise the last I'm going to say about that. So I'm going to start off with a description of my monolithic table. I just call it facts. It's pretty generic. It's got an ID column. It's got 2 big int values. It's got something which is a pseudo foreign key. I call it a pseudo foreign key because I'm not actually adding a foreign key constraint, but it is a pointer to another table. And I've got a big text column, which is actually just populated with an MD5 hash of the other values in my tests. Create a few indexes. Don't bother indexing the text column because I'm never going to query against it. Nothing really out of the ordinary or particularly spectacularly interesting here, but I want to cover my bases. Also, the table that I'm foreign keying to is over here. I called a category, an ID, and a text. The text field was just the hexadecimal representation of the ID, but that's fine. I only put in 65,000 rows into that. Yeah, no, nothing interesting there. So the monolithic table, getting right into insert times. The monolithic table slows down as you insert into it. This is not terribly surprising. I ran this a couple of different times. These tests, for what it's worth, were run on EC2 and RDS. I was using EC2 to run my scripts, and RDS using provisioned IOPS to get as consistent speed as I could, given that it was on the Amazon cloud. This peak showed up in every run. I'm not sure why. But yeah, we just shot up. This is the y-axis there is the number of seconds that it took to insert 1 million rows as we moved forward in number of rows. Okay, I was batching the inserts into 1,000 rows per insert statement, and I was batching the transactions into, I think, 10 statements per transaction. And then I was taking checkpoints every million rows. As you can see, I ended up with 100 million rows in my table. I cut this graph off because I wanted to show the bottom here, which is that the speed of inserts when you don't have those indices on the table, right? And if I had gone much further, that would have been even less visible. I assure you, there will be more graphs where the small numbers are invisible, so enjoy it while you can. Is width, yes. So we've got 4 indices. We've got the ID and the integer values, and yeah. So yes, integer overhead on table insertion, not a myth. That's a real thing. It has significant impact. I went through the trial of doing partial index inserts. If you're familiar with partial indices, you'll recognize this. If you're not, it's a pretty neat Postgres feature. You create an index not on the table, but on a subset of the table based on your conditions, right? So instead of having one index for the ID column, I had 10 partitioned out by 10 million rows apiece. Let's see. And we saw some slowdown, but since I was progressing serially through the IDs, as soon as I got to the next index, speed dropped right back down again. The throughput improved again. And that just continued on and on and on. You'll see this pattern in other slides, perhaps not surprisingly.
This one is really the full index, right? The other one.
Correct, and I cut this off as well. Sorry about that. Let's see here. And finally, I tested partitions on inserts, right? Partition triggered partitions. So I'm sure has anyone here not dealt with partitioned tables in Postgres before? Okay, a couple of people. So Postgres doesn't, as an earlier speaker put it, Postgres doesn't have partitions. What Postgres has is an old class object model that got overridden, so that the partitions is actually its primary use case as far as I know at this point. What you do, this is I'm putting this statement up. There are a few different ways of constructing this statement. This is what I did. You create a table. You tell it, importantly, to inherit from the parent table, and equally importantly, you give it a check condition, right? And that check condition is what helps the Postgres planner later on only target the tables that are relevant to the query. Okay. And again, we've got a nice, I'm comparing both the partition trigger here to the monolithic insert here, and this red line here is the partition indexes, partial indexes. So you can see the exact same pattern, the exact same camel hump pattern. Triggers are slower than indexes. Unless you don't have indices on those child tables. Obviously, I can't compare the partial index situation with no indexes, but I can compare it with the trigger-based stuff. And again, we get a nice flat line here. In fact, if you don't have indexes on your tables, dynamic triggers will operate exactly the same no matter how full the table is, no matter how many partitions there are. Right? It looks like we've got 3 lines here. We've actually got a bunch. This is the speed of the monolithic table insert with no indexes. Then here we've got 10 partitions, 100 partitions, 1,000 partitions, 10,000 partitions, and then up here we've got 50,000 partitions, and I don't know why that happens.
Why do you insert the partition? Do you insert directly into the child table, or just insert in the parent table?
So I'm inserting in. So the question is whether I'm inserting directly into the child tables or through the parent table. In order to test the trigger functionality, I'm inserting into the parent table. I have attached a trigger to the parent table, which then redirects the insert to the child tables. Now, note that I'm saying here this is the same for dynamic triggers. That's a slightly important word. Let's talk about triggers. There are a couple of different ways of constructing them. You can construct them as a series of if statements, like so. Probably nothing terribly confusing to you. For those who have used partitions before, you've probably seen this sort of thing. I am testing against my partitioning key. I am inserting into a subtable as appropriate. And I'm doing this for however many tables I've got. In this case, this is an excerpt from the 10 partition table trigger. But again, I did 10, 100, 1,000, 10,000. You can have a more informative exception if you'd like. That's entirely up to you. Ideally, you'll never run into it. And then you importantly return null so that it does not get inserted into the parent table. A dynamic trigger looks like this. This is how I'm defining if versus dynamic. It's a simpler format, right? I'm figuring out what the name of the facts table subtable should be based on the ID. I'm doing a simple integer division, appending it there, and executing this dynamically created SQL statement. Right? Any questions about those? Cool. If triggers start much faster, and then they ratchet up. As you go down that chain of if statements and else if statements, eventually they get slower than your dynamic query. And again, comparison, the monolithic no index. This is a no index situation. I'm not reproducing any more index inserts for you because they were really long running, and just getting a few trials in was a pain. Let's see. So the same pattern holds for case statements. That's another way to construct the if trigger, is to replace the if statement with a case statement. Again, it starts out really fast. If you're on the first partition in your if statement, it's not as fast as a monolithic, right? But it's faster than your dynamic triggers. This was 9.3. This is the only version that's available on RDS, so 9.3.3.
So I'll go back to the previous slide.
Sure.
Each step on the
I'm looking at this, and even though there are chunks, but I'm thinking there's about, I don't know, 10 steps than what I'm looking at.
It's exactly 10.
Related to how many ifs inside of the if statement.
Correct. So if we hit this if and insert into the first facts table, we're at this level.
And the second one is?
And the second one
Okay.
hits that layer. And we step up. Yes?
This is largely speculative, but if you reverse the order of those if conditionals, I wouldn't be surprised to see that staircase go the other way.
You're correct. Also, another thing which I tried was shuffled IDs, shuffled ID inserts. And if you shuffle your ID inserts, a lot of these peaks and valleys go away. The indexed stuff slowly ratchets up rather than boom, 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 boom. This stuff is much more even because you're mixing and matching. Was there another question back there?
Yeah, so
This
this is just 10 partitions?
is just 10 partitions.
So this will write 50,000 times 50,000 partitions?
Yes. Yes. I do this so you don't have to. Yes.
There's another variant of the if-else partition that I've done before. It's difficult to generate, but you can do it by machine, and that's to have the if-else part is a tree, where each time you're dividing the population of partitions in half, kind of like the way an index works. So with those ones, you'll just have a logarithmic decay in runtime, which is relatively insignificant even with huge numbers of partitions.
All right. So the suggestion from the audience: if you construct your if trigger using nested ifs, so instead of were you doing binary divisions or something like that? So, for example, if this were, I could use this as the framework for a 10,000 table trigger by, checking on the ID at this level and then checking chunking it into tenths at a sub if and then chunking it into tenths at a sub if down the line, and that would in fact produce, as you suggest, sort of a log 10 increase rather than a stepwise linear increase. Any other questions?
Just on the time, I assume that's time on the vertical axis?
It is. It's
Milliseconds or seconds or what?
this is a number of seconds to input a million rows. The graph axes get a little wubby later on. I was doing a lot of aggregation, so I apologize in advance for that. Case statements. The break-even point for this ratcheting seems to be around 9 or 10 partitions, which you can see visually. You can verify that visually. Does this mean you should never use dynamic triggers? Or does this mean you should only ever use dynamic triggers? Not necessarily. Instead, be aware of the cost, right? You can mediate the cost, as you suggested, and you can also do something that you in the back suggested. You can set up your if statement so that if you're partitioning on date, which a lot of partition schemes are doing, you get recent data as a regular basis, and you get old data only occasionally. Have the most recent month or the most recent date be the first if, right? And then have everything else come after that. That will get you the benefits of speed up of the if statement in the majority of your cases, which is really what you care about.
Is the cost for the dynamic triggers coming from the computation of the, I don't understand how you get it.
So there are two causes for the cost. So the question is where the extra cost here is coming from for the dynamic statement. What's that big thing? There are two. One, there's the string concatenation. The division isn't a big deal, right? But the string concatenation is a little slow. The big one is the fact that it's issuing a dynamic execute. So that's the big overhead. But again, it's not a huge amount of overhead, in comparison to some of the other stuff.
So just a follow-up, if I can extract that out of the application logic and push it down and just not use the trigger, but just have constraint exclusion to query out, would I see a better performance?
So the question is, if you could abstract out the logic away from Postgres, into your application layer, could you see better performance? And the answer is yes. You can see monolithic table performance on your inserts if you do it at the app level. There are situations where that works and there are situations where that doesn't. If you are predominantly inserting things into the same partition, which often happens again with date-based partitioning, then that makes a lot of sense. You just take all of your stuff and bulk insert it into your target partition. If you are inserting a whole bunch of things and you're partitioning, in my case, if I were doing the shuffled order ID insertion, that wouldn't help me very much at all because I would have additional logic to separate them into buckets, and that would be at the app level. So I would experience a slowdown. It just wouldn't be at the Postgres level. So, all right. Any other questions on trigger structure? Yes.
I might be jumping ahead, but on retrieving data selects similar overhead?
Welcome to the last 2/3 of my talk. The question is there similar overhead on retrieving statements, on retrieval statements? In retrieval statements, you're not using triggers, right? You're using Postgres's internal constraint, what's the word I'm looking for? Constraint, exclusion, thank you, constraint exclusion. Correct. So if you construct your queries correctly, you're using constraint exclusion, which will limit the number of subtables that you're querying against, which should give you a speed up. There is some interesting performance stuff going on retrieval at various different numbers of partitions. But at this point, I'm going to leave triggers behind. We're no longer inserting data. And we just have tables that we're reading from, and it's a vast new world of interesting.
Before you leave triggers behind,
Yes.
I don't have a question about the triggers, but I do have a question about how you would get so many partitions.
Okay.
Because in our environment, we could only get up into the 900s. We never crossed 1,000 before Postgres fell down. Are you going to cover that? If you're going to cover that,
So the question is, how did you get so many partitions? Apparently, in your environment, Postgres fell down after about 900 partitions. I don't know. I don't know what it was that caused Postgres to fall down in your case. I'd have to look. All right. So it wasn't a physical constraint. It was a practical constraint. So I'm the only user on this database, right? I set up in order for consistency's sake, I set up several identical databases and ran them separately every time. If you're doing these sorts of shenanigans on a production database, shame on you. This is what lab environments are for. That said, in production, the way we get a couple of thousand partitions on a given table, we have a script that runs every night, tries to create the partitions for the next 6 months, and if it runs into table locks, it punts until the next night. So it's a pretty simple script. It just tries and fails, tries and fails, tries, and hey, we've got another month's worth of partitions. So another thing before I leave triggers, a question for me. So how do you deal with falling off? How do you deal with that weird ID error? How do you deal with falling off the edge of your partition world? And the answer is I don't. I didn't. There are ways of constructing your triggers so that there's actual DDL in there. So if you hit a partition where a partition should be and there's no table there, you can create the table dynamically. All of my experiences has told me that this makes the triggers really, really slow, so I didn't bother actually testing it in these environments. And as he points out, it makes your logs very noisy, yes. All right. Any other insert or trigger questions? All right. On to the crazy. So, explain times for a table scan. Explain times for a table scan should be short. Here we have a monolithic table. We've got 10, 100, 1,000, 10,000, and 50,000 partitions. Right. And that is, in fact, 70 seconds. Took 70 seconds to explain a table scan when I had 50,000 partitions. But the actual table scans are also varied, but not nearly as much. Sorry, this is not based on 0. This is also seconds. We've got a little less than 2 minutes, around 2 minutes, and then up to 3 minutes. Right? It's not great, but up here we're dealing with 50,000 tables. Scanning 50,000 tables and aggregating against them in 3 minutes, not so bad. Also, that last graph, I want to point out this looks like a hockey stick. It's not. If you look at the actual axis, then we're normalizing. We're actually question in the back.
Yeah, sorry. How much data is in these tables?
So do you want the actual size of the tables on disk, or so there are 100 million rows of the table size that all of the no nulls, all of the fields populated. So 3 big ints, an int, and 32 character text field. Interestingly, the table sizes were actually, the total table sizes, including all partitions, were very consistent. They were about 17.5 gig, in which was larger than RAM. Don't worry. There were 2 exceptions. One, partial indices had so many additional indices that it bounced the size of the table up to about 25 gig. And 50,000 partition tables, I didn't bother creating any indexes. There were only 2,000 rows per table. So the table size actually dropped to about 11 gig.
Do you remember what the stats target was set at when you collected the stats on these tables? Lower high, because having stats can really hurt planning time sometimes.
So I used standard, just the off-the-shelf Postgres config that was provided by RDS, except for one difference, which I'll get into later, but it was not related to stats collection. All right. So for reads, in addition to the table scans, I ran 1,000 each of these scenarios on every one of my partition numbered things. Range queries, ID is between this and that. Range queries with a secondary condition, so range, ID between this and that, and int val1 equals the other thing, right? Range queries joining on a separate table, so facts F, categories C, where ID between this and that, and C dot name equals FFFF. Then I ran some these are particularly interesting. Some secondary conditions only, so I was not constraining by ID, so I was not getting constraint exclusion, and also secondary and tertiary conditions. Not all of these produced interesting results. Some of them were basically reproductions of other results, and at a certain point, things got a little weird, so we'll get there. So random ranges, just the explains, right? Just the planning time. Boom. So this is 1,000 statements. This is a total number of seconds. We've got pretty low. This is about, I think, 10 times that, and this is about 10 times this. Right? So if you run 1,000 selects on the excluding key on a 10, 100, 1,000, 10,000, then it'll take over 5 minutes. But the executes were shorter. Actually, I'm sorry, this is not 10, 100, 1,000, 10,000. This was monolithic partial index 10, 100, 1,000. When I actually executed, we got an improvement over time, right? So the monolithic table, the partial index table, did not do that well. 10 partitions, 100 partitions, 1,000 partitions. Now there's a question in the back of your mind. Where did the 10,000 and 50,000 partition times go? I pulled this statistic out because I found it interesting. The percentage of total time for a statement that was devoted to the planning. Again, I put this on the actual axis this time. So we've got 1 table, 100 tables, 1,000 tables. It's not quite linear, but it's remarkably close to linear. I have no idea what that means. I just was like, oh, I'll do some division. This seems interesting. When I do a range query plus a secondary condition, things got worse in the large number of partitions area. Right? This, again, is just the explain times. And this is a little less than a half second. This is less than a second. This is about 6 seconds. And then over 5 minutes. Monolithic, 10 partitions, 100 partitions, 1,000 partitions. This is the execute times for those same queries. A second, 2 seconds, 8 seconds, 2 minutes. Now, this was 5 minutes to plan, 2 minutes to execute, 1,000 queries. So we crossed a barrier there, right? When your explain time takes significantly more, well, over double the time that it takes to actually run the execute, then you've turned a corner. If I query against non-partitioned constraints, just the secondary values, there are numbers here. There are bars here, believe it or not. This is, again, number of seconds. So that's less than a second, less than 3 seconds, less than a minute, over an hour. You may be beginning to see why I stopped doing the 10,000 and 50,000 partition tables. So, over an hour. This is just to explain, just to plan the queries. And again, you may have asked what happened to this 50,000 partition table. We hit a limit. I hit a limit. I hit a limit somewhere between 1,000. Somewhere between 1,000 and 10,000, it gets even worse. But between 100 and 1,000, there's something there. But I didn't hit a hard limit. I was able to get 50,000 partitions into a database, and I was able to query against them. Remember, I was able to do a table scan against 50,000 partitions, right? So Postgres is capable. But there is a hard limit. Remember, I teased there is a hard limit. I originally planned 50,000 seems a strange step up from 10, 100,000, 10,000, right? Why not go to 100,000? I was planning to. That would only be 1,000 rows per partition rather than 2,000 rows per partition. I was actually planning on doing 100 million partitions. There was going to be a Dr. Evil macro and everything. 100 million partitions. I wrote trigger code for it. It's a dynamic code. It takes the ID, it creates the table if it doesn't exist, and sticks the value in there. 1 row per table. It would have been very large because 1 row is much smaller than the default page size. That proved difficult. So I actually managed to get 100,000 partition tables into a database, and I wasn't able to get anything out. I wasn't able to describe the database. I wasn't able to do a /d. I wasn't able to drop the tables. Drop table facts cascade, boop. If you search for this error, if you search for that phrase, one document shows up. And no, well, if you search without error colon, then the source code shows up. But if you search for that phrase, one document shows up, and it doesn't really explain what happened. It just says, oh, you run into this if you partition by too many things all at once. Well, that's not terribly helpful.
So you drop the char table you created, or you drop from other tables?
In order to get this message, I issued drop table facts cascade. Facts is the parent table, and cascade is drop everything that relies on it. But I was hanging trying to drop individual fact tables. I had to terminate the RDS instance and start a new one because Postgres became completely unresponsive. I couldn't terminate the connection. I couldn't reboot it. Postgres wouldn't shut down.
Was this 100,000?
This was at 100,000. This was not at 100 million. So I tracked this error down. It is in the source code, and apparently only one person has ever run into it and bothered to, or lived to tell the tale, I guess. It involves testing against a macro called isSpecialVarno. Apparently, if your nodes, if something is special, then you get an error. It's in primnodes.h. And specifically, it's testing against inner var, and it tests against the number 65,000. That is your hard limit. 65,000, well, 64999. If you have more than that many tables involved in a single query, even an administrative privileged query, you will run into this error. And you will join an elect few. So, yeah, it was fascinating, just trying to figure out what was going on, because I tried to select and it just never returned, and I tried to describe and it never returned, and I was like, screw it, I'm dropping the table, and it churned for a half hour and spat out that. So,
Just submit a patch and have the value raised.
well, so if
That'll fix the problem, right?
so I was just told to submit a patch. If I had had more time and hardware on which to run this, rather than running it on RDS, I totally would have put up that value and tried to recompile, rebuild Postgres, and hoped that it was okay for it to be larger than 65,535.
Did you have to wait a long time to get that error message, or did it come right away?
Yeah, it might have been 20 minutes, but it was a long time. Yeah, it felt like a half hour.
I was kidding about the patch, by the way.
Yeah, it's very tempting for me to look back at these explain times and be like, we don't need parallel query execution. We just need parallel query planning. Then we could partition to our heart's content. Sadly, we have a limit. That's all I got. Thank you for coming on this fascinating journey with me. I would recommend the conventional wisdom. So to sum up, the conventional wisdom that you should not use more than 100 partitions per table, there's some value to that. But one of the questions that I would like to answer is, where between 100 and 1,000 partitions do you start seeing that cliff? I was trying to get a nice scatter shot, and there's somewhere in there where there's a turning point, and I'd love to know where that is.
Yeah, I'm sure it depends on the individual use case, because it looks like the decay is exponential, so you just have to see what works for your site.
Right, and so the decay is probably exponential. My question is whether it's exponential based on simple number of tables, or if it has something to do with the number of objects attached to the table. If I had done this with fewer indices, would it have made a difference? That sort of thing. I would also be interested in doing this on different Postgres versions to see whether this has improved over time or not. So, question in the back?
Larger partition sets will perform table scan or index lookup inside this ridiculously huge partition set.
Yes, complex joins will fall apart. If you try and join two different tables that both have 1,000 partitions apiece, then you're going to have fun. We do that in production, just FYI. There's a question in the back.
Just a comment that if you know your data and don't mind doing the maintenance, like you were partitioning on an ID, that's always going to go up.
Correct.
You know that once you finish inserting into one, you can adjust your trigger so that it never inserts into that partition again. So you can keep your number of if statements down to just your current, what you're currently loading. I'm planning on partitioning on date, and I know that once I've loaded a day, I'm never loading that day in again. It's there. So I can do the partitions actually by month. So once a month is done, I don't need the if in the insert trigger anymore.
So the comment is that if you know a priori what partition your data is going to go into in every case, then you can vastly simplify your trigger and just use an if statement. If it's what I expect, send it where I expect it to. Otherwise, throw an error. And that's absolutely true. I don't have the liberty to do that. There are times when we need to insert data from 2013. So yeah, we need to be aware of that. But we do most of our partition inserts, insert divisions on the application side. Because when we do inserts, it is grouped by date in fairly large chunks.
Yeah, actually we have a lot of tables too. We have with 40,000 tables. But then there's a issue when we open the PGMU, it's hung in there. Tricky, I think, to do that, or you have some other.
So yeah, if you have 40,000 tables, then certain GUI tools might not treat that well. What I do for most of my databases is for these large partitions, I actually create a schema per parent table. So the facts table here, there would be a schema called fact schema or however you wanted to name it, and inside that schema would live all of the partitions. So if you're just doing a query for the tables that are in your search path, which I assume is what pgadmin is doing, then that should return a much truncated version, basically just your parent tables. Is there a question in the back?
I was going to ask you, but sure. Have you looked
Shouldn't stop you. Yeah.
at nested partitions at all?
So nested partitions. So there are a couple of different things you could be. So the question is, have I looked into nested partitions? There are a couple of different things you could mean by nested partitions. There is the partitioning by more than one key, right? So let's say I'm partitioning by ID and int val1 in the facts table example, right? So ID is partitioned into 10 partitions, or 10 sort of logical chunks, which are then themselves partitioned based on a secondary key int val1, which is also divide up into 10 things. So you end up with 100 tables. I didn't test that case here. And the other situation that you might be talking about is you have a table, a parent table, and then you have a bunch of inherited tables, so maybe 10 inherited tables inheriting from that parent table, and then for each one of those is actually, it is actually also a parent table. So you have 10 tables inheriting from this thing, inheriting from that thing. I was running into enough problems. Didn't get to that. I find it an interesting case, but yeah, then you would have to manage 11 sets of 11 triggers, right?
Start writing code to manage the rules.
Correct.
I've tried that.
You've tried the nested.
Yes, but not with 1,000. I just tried that with about 100, and it worked remarkably well. Right.
All right.
I didn't do it, but it worked well. It was fine. Like the constraint exclusion was perfect. Everything went well.
So we've got a +1 for nested inheritance tables. Is there a question over here?
No, I was just saying, I also have tried it with multiple ones and inheritance on the tables, but not trying to get into thousands.
Yeah. Well, there are only a few of us that can be that special.
It seems like you learned that in the case with at least some of those tests, the constraint exclusion wasn't done first. Because if it was, I can't imagine why planning time would have been on the order of umpteen minutes.
So the comment is that the constraint exclusion must not have been the first thing done in the planner, because otherwise it wouldn't have taken so long.
I assume.
That seems a reasonable assumption. I haven't actually, the only way that I've dived into the internals was to track down that error code. I didn't actually look at the planner. The planner is a little bit here be monsters as far as the code goes. So I didn't really dive in and figure out where the constraint exclusion was getting added. Apparently, it's either not first, or it's kicking off in sort of a nested loop or some other exponential pattern way. Is there a question in the back?
Yeah, I was wondering if you were going to continue these efforts and publish them online, so we can keep up with the partition.
Well, so the spirit is willing. This was done out of pocket though. So I was originally planning on doing this on hardware. I acquired a Dell PowerEdge, just was sitting on my desk at home, propped up so it had airflow. And I had run several tests on it, and then it failed to boot, and had bad power supplies. And then I had another hardware unit that failed to boot, had BIOS problems. And I had another hardware solution that was going fine for about 12 hours, and then the fan stopped, so it went into low power mode. So all of my times dove. So that's why I ended up on AWS. And unfortunately, it costs money, and this wasn't something that was subsidized by my workplace. So. And even if it had been, they might pay for it, but not actually let me spend the time to do it. So I am very interested. If you want to pick up the torch, go for it. I am behind you all the way. I will happily share my code with you. Otherwise, we'll see. Maybe next year.
Do you know if there is any plan or that we're going to change the internal so that make the partition more efficient, like say Oracle?
So the question is, can we make partitions like Oracle? That's a poor rephrasing. Can we make partitions more efficient inside Postgres? Is there a plan to do it? There are like a dozen. None of them have actually sort of picked up and been accepted by the core team. There does.
On the to-do list forever, and you're right, every month or two somebody mentions another vague proposal on a way to do it, and it gets chatted about, and then more important work.
Yeah, it is a perennial to-do list item, and because it's an open source project, it comes down to someone being motivated enough to do it, and yeah, it would be nice because the inheritance partitioning scheme is based on these constraints, which are not necessarily exclusive from one another. We're in an object hierarchy. If we go all the way back, pardon my fast rewind here. So if we go all the way back to here, there is nothing that requires that this check constraint be exclusive from other check constraints. So we could have an overlapping ID set, or we could have completely arbitrary check constraints that check against ID for this table and check against int val for this table and do all sorts of crazy stuff, which is useful for the general object class hierarchy case, which is what it was built for. But as a partitioning scheme, it leaves a lot to be desired. There's a whole lot of assumptions that the planner can't make because it has to check all of those constraints, right? So yeah, there is room for that. There's not been a whole lot of drive for it because we've got a patched solution in the meantime.
So with constraints that won't be mutually exclusive, does it bitmap, or how does it deal with finding the checking out tables which it should be looking at?
So if it, I mean, we're talking about hypotheticals. If it did have like exclusive constraints, exclusive check constraints, then there are all sorts of ways that you could manage that would not require you to check every single one. You could instead store a map or something like that, which would allow. I leave it up to the future implementer, whoever he or she may be. Lots of graphs. All right. Any other questions? I think we're running a little short on time, but I'm happy to answer any other questions. If not, thanks for having me. Rentrack is hiring. We're hiring programmers and DevOps, a DevOps team lead. We're looking for a DevOps team lead. And we'll be hiring DBAs pretty soon, so let me know. Come up and talk to me.